Yeah, welcome everybody. Thank you for coming. So this is a Bioinformatics Live presentation for today. Basically, I'll just run quickly through the slides. You've probably seen them all before. Just introducing us, who we are. We're the Bioinformatics Core Facility. There's Sean, who's the facility manager, Dan and myself, who are bioinformaticians. And this series, we do a series of monthly webinars. They're designed to be short and just focusing on a single topic. And we're just trying to share some skills which will help you use the servers effectively for your research. So I'm going to give a bit of a presentation and a demo this week on Conda. And then afterwards, there'll be some time just for you to ask questions if you have any. So we've got a few upcoming workshops. These are actually going to be in person now in Peter Wilson. You should have received an email about these. So on the 31st of May, we'll be running a session on analyzing genomic data in R. And then the 7th of June, we will look at high-C data analysis. And then the 21st and 22nd of June, we'll do a 2-day workshop on RNA-seq data analysis. And after that, we've got a few ideas of things we'd like to do. So automated workflows, using the Ensemble database and some other things, but probably more focused on analysis. But we're always open for suggestions, or if anybody would like to present a Bioinformatics Live session on what they've been doing on the servers in Bioinformatics, then that'd be fantastic. So just let us know. So this week, we're going to be talking about managing your own software with Conda environments. Last time, I discussed running software on the BIFX servers, and I explained that we were using Singularity containers to manage our software, which made it possible to install multiple versions of pieces of software on the servers at the same time. If you want to manage your own software, you can build your own Singularity containers. It's quite involved, but it is a good way of doing it, a good way of making it possible to do reproducible analyses for your projects. We recommend Conda because it's just slightly easier to get into. It's a convenient way of managing your own software. So I'm going to walk you through how to get it set up and how to use it today. So first of all, I'll just introduce Conda, then I'll run through installing Miniconda using the command line. And then I'll talk about setting it up. So setting up the channels, I'll discuss what those are and how you get them set up. And then I'll talk about using Conda environments, which are something that Conda uses to let you manage different software stacks, possibly for different projects, which is very useful. And finally, I'll just tell you how to install software into those environments and how to export and potentially create environments using the exported specifications. So just getting started, basically Conda is a tool. It works on Windows, macOS, and Linux, and it can be used to manage your own software. So that could be Python packages or bioinformatics tools. And a good thing about Conda is it lets you define multiple environments for different projects. And you can install different software stacks in each environment, and you can switch between them very easily, which I will demonstrate. And another good thing is it allows you to share your environment specifications. So you don't have to manually take a note of which versions of all your bits of software are installed when you do an analysis and you want to share it. You can just export it and it will give you a file with all those details. So if you look for Conda online, you will see that basically there are two distributions of Conda that you can get hold of. There is Miniconda, which is basically just the command line tool for managing the Conda environments and getting the packages. This is what we recommend because it's basically everything you need to use Conda. The Conda command line tool is there. And if you want particular packages, you can easily use Miniconda to install those packages, and it will just bring those in from the internet. The alternative is Anaconda, which is a kind of fuller distribution that includes a GUI and a large number of pre-installed packages. So most of the pre-installed packages are for data science generally, rather than bioinformatics. So you will probably find that you will have to get your packages and software tools that you want from the internet anyway, even if you install Anaconda. And if you're using it on the server, you probably aren't going to use the GUI app. So for those reasons, we recommend just using Miniconda. So the rest of this talk, I'll just be talking about using Miniconda. So the first thing you want to do to get Miniconda set up in your environment or in your home directory is to install it. And you can do that on the command line. So I'll just run you through that quickly. The first thing that you want to do is go to the website where the Miniconda installer scripts are shared. So you can see it's https repo.anaconda.com/Miniconda. And this gives you a big list of all of the Miniconda installers. So they've got installers for each version of Miniconda and for different platforms as well. You will see that we've got Miniconda 2 and Miniconda 3. Miniconda 2 includes Python 2, and Miniconda 3 includes Python 3. At this moment, Python 2 is deprecated, so I would say you probably always need Miniconda 3. And the version that I'm going to be looking at today is the latest version for Linux. So Miniconda 3-latest-Linux x86-64. So I'll show you how to install that via the command line. So I'll go to my command line now. This is might take a second just to log in here. So what I'm doing is I'm running an Ubuntu Linux virtual machine, which is just a blank installation of Ubuntu. So I'm installing basically from scratch. So I'm going to use the wget command to go to this repo dot, I'll say continue IO. Those URLs point to the same place, Miniconda and Miniconda 3-latest Linux. And the one I want is x86_64, which is the 64-bit version. It's a shell script. I'm just going to use wget to download that. And it takes a few seconds just to download it from the internet. Almost there. And it's always a good idea when you've downloaded something from the internet, just to make sure it is what you think it is. So a good way to do that is using the md5 sum command. And that will give you the md5 checksum. You can then go to the website and you can check that that checksum matches. So you can see that one starts with 7843DD and this one 7843DD. So that looks like the same checksum. So we have actually downloaded the right one. And then if I go back to my shell, I can use the sh command, which is just shell to run that installer. So you review the license agreement and you press enter to continue. So when you press the return key, it just shows you this license agreement. You can press space to get all the way through it. And it says, do you accept the license terms? Type yes. And then it says Miniconda will now be installed into this location. So it's your home directory. My user is called Conda. So instead of home Conda, it will be home, whatever your username is. And Miniconda 3. I'm happy with that location, so I'll press the enter key. And that will mean it will start installing the software. So it's just unpacking the software and it will install it into your home directory. So I'll just leave that to work for a second, and I'll put it back on the slide. So if you want to follow along, you can follow the steps on this slide. It probably takes a few seconds to run through the installation. Just check how it's doing. Show that again. Yeah, it's still unpacking. So it will probably take a bit of time. You can see that there are a few different bits of software that are getting unpacked from the installer, what the installer is downloading. So basically it's creating your base environment and it's going to install some software in there. The way Conda works is it prepares transactions. So basically all the software is installed atomically, so that if the installation fails halfway through, it will roll back to the last stable state. So it means you don't get a kind of broken software installation. So now everything's been installed. The thing it's asking us now is whether you want to initialize Miniconda 3 by running Conda in it. That is something I would say yes to, because it's actually useful to have the Conda command on your command line, and that's what this gives you. So I'm going to say yes, and it just updates the bashrc file to include a couple more commands, which just make sure that the Conda command is there. And the final thing I'd like to do is to update Conda, just to make sure I have the latest version. So I can do Conda update Conda. Oops. So if you have this, because it's modified the bashrc command, you actually have to load bashrc again to get the Conda command. So source just will run your bashrc again to pull in that new code. And then hopefully Conda will be there. So now we have our Conda command and it's working. And that's a good way of checking that your Conda installation has worked properly. And you can see actually, when we source the bashrc again, you can see now we have base in brackets before our command prompt. And that basically means we're in our base environment. I'll describe what that is shortly. So it's just checking all of the packages in the base environment and checking Conda just to make sure you have the latest version. And it's found some packages which it can update. So I'm going to say yes, I'd like it to do that. It always gives you the option to proceed. It tells you what it's going to do, and then it asks before it does it. So now it's just downloading all of the new packages that we've asked it to download and to update. And eventually, once it's installed all of those, we'll be finished and we'll be ready to go. So that's it. We've now updated Conda and we're ready to start configuring it. So the next thing that I like to do is to set up Conda. So there's a useful command which allows you to keep track of your installation called Conda info, and it just gives you some basic information on your installation. And one of the things that it tells you about is Conda channels. So basically, if you want to install software using Conda, you need to tell Conda where to go online to look for that software. There are various repositories on the internet that different people maintain that Conda can go to find software packages to install. If you want to do bioinformatics and get access to bioinformatics tools, there is a channel called Bioconda, which is dedicated to bioinformatics software. There's also a channel called Conda Forge, which includes a lot of general packages, which are often useful. And a lot of the time they're required by the Bioconda packages for them to work. So what we need to do is we need to add both the Bioconda and Conda Forge channel so that Conda will be able to find bioinformatics software. So I'll just demonstrate that now. First, I'm going to do Conda info just to look at what our installation looks like at the moment. So you can see our environment is home Conda Miniconda 3. We're on Conda version 4.12. And our channel URLs, currently we've got 4 channel URLs, and they basically are the repositories that come by default with Anaconda. So Bioconda is not currently there. If we want to add Bioconda, we can go conda config, add channels Bioconda. And that's basically will add that channel for us. If we run Conda info again, you'll see that now we have Bioconda at the top of our list of channel URLs. So I'm going to do conda config append Conda Forge. So the reason I do append rather than add is that I don't want Conda Forge to be at the top of the list. I'd rather it was at the bottom of the list. So add puts it at the top and append puts it at the bottom. And when Conda is searching for packages, it starts at the top of the list and goes down, basically. So if I just append that, oops, what have I done here? Oh, channels. So Conda config append channels. Yeah, I need to tell it what I want it to append Conda Forge to. So it's a channel. And when I do Conda info, you can see that now we have Bioconda at the top, then the Anaconda channels, and then we have Conda Forge at the bottom. So that should be enough to set us up so that we can now use Conda to work with bioinformatics software. So the next thing I'd like to talk about is using Conda environments. So every time you install software using Conda, you install it into an environment. By default, the Conda always provides you with one environment called the base environment. And you're able to create extra environments, which you can name. My general advice would be that you always use a named environment to install software. If you have a named environment, you can remove it, you can rename it, you can generally work with it more easily. The base environment, because it's always there and provided by Miniconda, is something that generally I like to leave alone. So I'll just demonstrate how you can create a named environment with Conda create. And then before using the named environment, you have to activate it. So you basically have to tell Conda to go into that environment. And finally, if you want to list your environments, there's a useful command called conda env list. So I'll demonstrate all of those things. So first of all, just looking at the Conda info output. I'll get that up again. So you can click at it. You can see that active environment is at the moment base. So we're in our base environment, and the active environment location is home Conda Miniconda 3. So that's the base environment that we don't want to change. So I will create another environment with Conda create. And it is Conda create -- name. I'm just going to call it my first environment. So what it's doing is it's just making this environment and putting the basic packages into it. So I haven't asked it to install any software in that environment yet. So it's just creating the environment. So it takes a few seconds to create the environment, but eventually it should complete. Here we are. So it's asking me whether I want to proceed with it. I'm going to say yes. And it's creating this environment. So it actually tells us that in order to activate the environment, you have to use Conda activate. You can see that we're still in the base environment. Base is still in brackets before I prompt. So I'd like to go into that environment and say Conda activate my first. And then you can see that my first environment appears in brackets before Conda at Conda VirtualBox. Look at Conda info again. You can see that the active environment is now my first environment, and it actually tells you this environment is in a subdirectory called envs inside the home Conda Miniconda 3 directory. So the next thing I'd like to do is just list my environments using Conda end list. Conda end list. You can see we've now got two environments. We've got the base environment, which comes automatically with Miniconda, and we've got my first environment, which I've just created myself. So another thing we can do is create additional environments. So I'm just going to create another one. I'm going to create name my second environment, just to show you that it's possible to create multiple environments. Proceed with that. So now when I do Conda end list, you will see my first environment and my second environment. Of course, if I want to go to my second environment, I can do Conda activate. So that's how you manage environments. the next thing you're going to want to do is actually install some software in these environments. So I'll just cover that now. So the most useful commands for installing software in an environment are Conda search and Conda install. So the Conda search command will tell you which software is actually available in the channels that you have. And Conda install will install the software that you ask for. You can install multiple packages at once with Conda install, and that's actually a good idea to do rather than installing everything separately. If you can do a single Conda install with the software packages you need, that will basically allow Conda to check the dependencies and see if there are any dependency conflicts between those tools. And then the entire installation of all the tools can fail if they're not compatible with each other. So that's quite useful. It saves time when, rather than installing things individually and getting halfway through and realizing they won't work together. So I would recommend that. You can also use the equals notation to choose a particular version of a tool that you want to use. So just to demonstrate that, I'm going to search for SAM tools. And this is going to search through all of my channels. So you can see it's loading the channels right now. And it will go down the list of channels searching for packages called SAM tools. And finally, when it finds those packages, it will give you a list of all of them, and it will tell you the versions that you can use. So typically channels will have multiple versions of software packages available. So you can choose which one you want to install. And as you can see, it can take a few seconds for that to work.
So it's probably worth saying here as well that you can search online. So you can search the Conda website for what packages are available. You don't just have to use the Conda search function.
Yeah, that's true. They have a website as well. The benefit of using Conda search is that it only looks at the channels that you actually have in the order in which you have them. So if you look for something online, it may be that the thing you're looking for is out there on the internet, but it might not be in the channels that you have, or you might not necessarily know exactly which versions are going to be installed using your channels. So it's not, I mean, if you know you have Bioconda, you can look in the Bioconda repository online, and you can be reasonably sure that you'll find the thing there. So that is a good way to do it, but as long as you bear in mind that not everything on the internet will be available necessarily in your setup. So this is taking a particularly long time, but hopefully it won't be much longer. So while that's loading, I'll just mention the final point on the slide, which is if you use Conda create to create an environment, the way I did before, you can actually specify the tools and the versions while you're creating the environment. So rather than creating a blank environment and doing Conda install to install some tools in it, you can just do Conda create, use -- name to give the environment a name, and then you can do a list of tools, just as though you're using Conda install. and it will create the environment and it will install the tools in it at the same time. Because Conda works atomically, if that fails, if it can't install the tools, then it won't create the environment. The whole transaction will fail. So that can be useful too, because that's a bit less cleanup you have to do if it doesn't work. So I'll just check how the VM is going. It's still loading. So basically, when you do Conda search, I'm not sure how long I should leave this working. I will, yeah, when you do Conda search, it gives you the versions, and then you can use that to build your Conda install command. I think what I'll do is I'll just stop this now, and I will do a Conda install just to show you what that looks like. Conda install SAM tools, so I'll give it version 1.15, and I'll do bed tools version 2.26, just to show you that I can install particular versions. Hopefully this will be a bit quicker, although it may not. And basically this will install these packages into the environment. So while that's working, I may as well keep going through this slide just to so that we cover all the information. Then I'll go back and demonstrate it. So the last thing I wanted to talk about is exporting and using Conda environment specifications. So one thing that you need to bear in mind if you're doing reproducible research is that sometimes different versions of the same software tools will produce different outputs given the same inputs. So sometimes somebody might write a piece of bioinformatics software and they might fix a bug in it, or they might update the functionality, which means that if you perform exactly the same command, it will actually give you a different output. And for that reason, if you want to make it possible for either yourself in the future or other researchers to replicate your analysis as closely as possible, it's important to keep a note of the versions of the software tools that you're actually using when you're doing your original analysis. So one good thing about Conda is that it actually allows you to export your environment using Conda env export. And that just makes a file which has the software tools and the versions included in your environment. And once you have that file, you can actually keep it or give it to another researcher. Because it's a text file, it's just a list of the software with the versions. It's very easy to email it to somebody or share it online so that another person who uses Conda as well can use that to build an environment which looks like yours, which they can then use to replicate the data analysis. So that can be a useful thing. So if I just go back to see how this is going. Yeah, so it's managed to find the packages. So you can see that there are a few packages which are going to be updated and a few packages which are going to be newly installed. So if I go back down to the bottom if I can, then I will just ask it to install these packages. Unfortunately, it's very unresponsive there. So I'm just sharing my local laptop now. So I've got an environment called SAMTools test, and I'm going to Conda install SAMTools equals. Actually, I'll do Conda search SAMTools just to show you. It'll be quicker on here. Yeah, this is generally quicker on the server. I think the virtual machine is slowing it down. So try and do this. Trying to make it a bit faster. So yeah, Conda search is very slow. So I'll do Conda install tools 1.15 and see what that does. So I've got a few packages to install, so I'll do proceed yes, and you can see it's just downloading the packages just to install the software in the environment. And it's doing it within a transaction, so it's just going to make sure that everything's installed properly. It looks like it's worked. So now I can do, if I do which SAM tools, you can see that my SAM tools executable is in my SAM tools test environments bin folder. So it's installed it into that folder. So we've got SAM tools version 1.15.1. So that's the version that we asked for. So now I've got the software in my environment. I'm just going to show you Conda and export. So this is the command that exports the environment into a text file. So it will give a file in the YAML format. So you can see it's got the name, it's got the channels, and it's got all of the software that's installed in that environment. So SAM tools is there with the version and everything else that it depends on. So this is the file that I could share with another user in order to create, to allow them to create another environment which is the same as my environment. So if I go back to the slide, you can see that you can use the Conda and create command to create a new environment using that YAML file. So I'll just have a quick go at doing that. Let's see if it works. So if I do conda and export into a file, so I can just pipe it to old environment .yml. And then I can do conda env create name new environment /f. So it's looking at a file and old environment YML. So that will just read all of the versions of packages out of this YAML file in the old environment, and it will load it into our new environment. So if I was another researcher and somebody had given me that YAML file, I could actually do that on my computer, and it would load in all the right versions of the software for me to replicate the analysis. This is a reasonably good way of doing reproducible in software environments, but it's not perfect. There are a few things that can go wrong with it. First of all, it really depends on the maintainers of the channel to keep the channels backwards compatible. So if the maintainer of Bioconda or CondaForge decides to take some packages out of those channels, then using a YAML file that references those packages won't work, because the packages will no longer be in the repository. The YAML file is just the text file that shows what the packages are and what their versions are. So it doesn't actually contain the packages themselves. So it does rely on these external repositories to keep the same versions of the packages. So in that sense, if you want a really reproducible environment, it can be better to use containers or virtual machines, which actually contain the software itself, rather than just a reference to it. Another thing that can happen is that some of these things can rely on shared libraries on your computer. The binaries are built for particular platforms. So if you are working on one platform and the other researcher is working on another platform like Windows, those shared libraries may be different. It is unlikely that that will result in different outputs, but it is still something to bear in mind. So if you want to be sure of doing reproducible analysis, then the best thing to do is to actually use a container or a VM. But this is a good kind of compromise. So it's a good way to actually document what versions of which packages are being used. And it's something that does actually work quite well a lot of the time, especially if you use common packages. So I think all in all, Conda is a pretty good system for managing software, especially bioinformatics software, because Bioconda is pretty well maintained at the moment. So because it's taking so long, rather than just waiting for this to complete, basically what it's going to do is it's going to make a new environment which looks just like this old environment. I think I can move on to questions. So if anyone has any questions about any of this, please let me know. Thomas,
I have a question here.
Oh, yeah, great.
So how, I think I understand how this works when you're within an environment, but how do environments deal with software that's already installed, like in a general? For instance, I have already installed some tools, but tools, all these things. When I create an environment in Conda, do I have to install the version I want within that environment, or is a way to say, okay, use this version that's already installed in the general? See what I mean?
Yeah, so basically what Conda does is it adds an entry to your path in Bash. which tells Bash to look at the Conda bin directory first.
Okay.
So if there is a tool which is not in the Conda bin directory, then it will then go back along your path to look for that tool in the rest of your path.
Right.
So you don't have to have every piece of software you might want to use in your environment.
So how does Conda know what is available outside the Conda environment? Does it make sense?
Well, it doesn't, to be honest. It will, so you can manage packages within the environment. What Conda doesn't do is prevent you from using anything else. So if you, in that sense, your analysis is only reproducible insofar as you use the things which you install using Conda. If you're also using other tools which you haven't installed using Conda, then obviously those could change.
Okay, and there's no way, and I cannot tell this environment to use. I'm using this other package that was outside.
Yeah,
everything has to be Conda.
Yeah, so there are ways of getting packages into Conda, but that's kind of outside the scope of this.
Yeah.
But if you want a completely reproducible software stack, where everything is included when you share it with another researcher, then probably containers, something like Singularity is the way to go.
Okay.
This is better if you just use
like, there are different levels of containment, I guess. So containers contain everything. Conda you can use for, okay.
Yeah, so this just is a way of kind of having a particular set of software tools with their versions that you can share.
Right. And I was looking briefly at something similar concept called RN to get environments based on R packages and stuff. So this is something I can use within Conda, or again, it's something completely separate.
So Conda is an alternative way of managing the packages. So you can manage some R packages using Conda. So you could do Conda install. There are a few packages called R-DEC for R-Bioconductor, that kind of thing, which you can install using Conda. Generally speaking, they're not that well maintained. I think RN is a lot better because it actually uses CRAN, which is the R archive network. So if I was doing R packages, I would use RM for that, rather than trying to make Conda environments. You can make Conda environments, but you may get to a point where you find your package isn't there, and then it's a bit of a pain.
All right. Yeah.
So we'll cover RN, but the next session next month as well.
All right, good. Yeah, thank you.
I think Thomas has a question as well.
I had, but you kind of answered it, because my question was, what is your experience with R and Conda? Because I tried, but I got defeated. Like, you could not make things work. There was old version of Bioconda, but you kind of answered that I'm not the only one who had problems with it.
Yeah, I think generally speaking, people in the R ecosystem don't use Conda. Conda is more, it originated in the Python land, and it's very good for Python packages. It's also good for general kind of binaries, things like bed tools and SAM tools. For R packages, there are some, but there aren't that many people maintaining them, so they're not as good as using kind of the R infrastructure, the R environment.
Can I ask a question?
Yeah, sure.
Sorry. So what I understand is so if I install the latest version of Conda, of the Conda environment, will it support all the latest version of the tools that I want, or?
Yeah, so you can choose which version of the tools you install. So you create an environment. So when I created installed tools in the environment, I used Conda install SAM tools equals 1.15, which is just a particular version.
Yeah.
But you can just say Conda install SAM tools without specifying a version. And then it will try and find the most recent version that it has. So if you want to install the latest version, then just don't specify a version number, basically.
Okay. But is it good? Is it a general practice to download old versions of tools and just use it in your package so that in your pipeline so that it's reproducible, like you get the result that you want and you know that it works fine. It has worked fine before. So is it fine to use outdated packages of outdated tools?
So basically, probably the use case for using outdated tools would be if you want to replicate somebody else's analysis and that person used those older tools.
Okay.
Because if you use new versions of tools to replicate someone else's analysis, you may get different results.
Okay.
And you may think they made a mistake in their analysis, when in fact it's just they were using a different version of the software, and that's why it gave a different result. So if you want to, another thing is with pipelines, there are some pipelines that rely on particular versions of software to give the output in a particular format. So if you try to run a pipeline with a different version, then it might break. So it's another thing to be aware of.
Yeah, similarly with your own stuff, Aparna. So, say you had run an analysis 4 years ago and now you have new data sets and you want to do the exact same thing. Like Al says, if you just are using the latest packages, then you might not be able to replicate what you did before.
Yeah.
As if, if 4 years ago you created a Conda environment, and then you had a list of all those software versions, then you can try to recreate, essentially run the new data in that Conda environment and run it the exact same way.
Okay. Cool. Thank you.
Okay. Any more questions at all? Great. Well,
can I also ask another question, which is related to my data?
Is it to do with Conda?
Yeah, it is to do with Conda. No, well, so basically, because the softwares that were there in the folder that I used, the softwares from, like the old bioinformaticians tools, I don't know what versions they were, but the pipeline worked.
Okay.
So when I rerun the whole thing and make a new Conda environment, I should ideally install the latest versions of whatever softwares I used and see if I get the same result, right?
Yeah, you could try it both ways. Probably what I would do in that situation is I would use the same versions to start with, just to verify that you can get the same result with the same software. And once I can do that, then I can try updating the tools.
Okay.
But generally speaking, there probably isn't much to be gained from updating the tools unless there's a particular reason, like there's a particular feature in a new tool you want to use.
Oh, okay. No, I just thought that it would be, I thought it was the best practice was to use the latest updated versions of tools. So if that's not the case, then.
Well, with bioinformatics, I mean, it's not something that's like a
software update or
a web browser or something where there could be security holes. It's just they might kind of update an algorithm or something like that. So it can be interesting to see how things change when you update the tools, but a lot of the time, unless they fixed a serious bug, which means that the old version didn't get correct results, then it's probably not.
Yeah, I'd say if you're doing an analysis for the first time, if you're doing something fresh, then install new versions of tools.
Okay.
If you're trying to recreate something that someone else has done or you've done in the past, that's where being able to use older versions is useful. All right, thanks a lot. How I would say that we'll send out a summary. We have documentation on Conda on our website, which will go through all those commands on how to install Conda, etc. So don't worry if you've been frantically trying to remember all these Conda commands. There's also a nice Conda cheat sheet available, which just lists out all the Conda commands for you for ease of use. As always, if anyone has extra questions on anything bioinformatics related on their projects or their analyses, we'll stick around for a little bit. Otherwise, we have the upcoming workshops, and we'll also have another Bioinformatics Live session next month, which I'll be taking everyone through creating projects in R. So yeah, other than that, thanks a lot for coming. Thanks to Hal for presenting. As always, we're at the whim of network connections when we're doing live bioinformatics. But hopefully everyone got a good idea of Conda and how to use it. And if you have any questions, then just come back to us. Thank you very much.
Thank you.